Organizations have much to gain when they include predictive scorecards in their reporting system. During this session, I'll be describing issues with traditional scorecards. I'll be describing how to convert historical-based scorecards to an integrated enterprise excellence predictive performance report out. I'll be using 4 actual scorecards to describe some issues that might occur with this form of reporting. With red, yellow, green scorecards, whenever a metric is red, action should be taken. If the metric is green, everything is okay relative to our goals. However, is there a better way? Another form of scorecard report outs is a table of numbers. Do you think that this table might have some confusion relative to interpretation? Is there a better way? We might look at our data from a time series point of view. Do you think that everybody would interpret such a chart the same way? Is there a better way? The final example is the time series record of numbers, where these numbers magically begin differently, start all over again when January occurs. The question is there a better way? Typical metrics view the metrics fiscally or unrelated to improvement system, provide point-to-point comparisons. Perhaps we might talk about or compare this quarter to last quarter or this quarter to the same time frame in a previous year. But what we really have is y is a function of x. That is, the output is a function of the inputs and the process steps itself. Effective metrics, though, view the enterprise as a system of processes, acknowledge the effect of variability, support long-lasting systematic process improvement. Metrics can take different forms in various organizations. However, do we have an elephant in the room that nobody's talking about? Is there a better way? To answer this question, let's examine a red, yellow, green scorecard in more details. Now, if we examine finance metric B, we notice that there's 33% red and 50% green. Now the question is that special or common cause? Dr. Edwards Deming, a number of years ago, coined these terms. And his use of these terms were primarily for low-level processes. For example, a manufacturing process where we wanted to identify an unusual event as a special cause so we could then fix this problem. Stop the presses, so to speak. That's not what this is. What I'm referring to is a 30,000-foot level view of our processes. Not unlike when we look out the window of an aircraft in flight, examine the terrain below, obviously we get a high-level picture of what's happening below the airplane. Similarly, 30,000-foot level reporting takes this form of view of our performance measurements. Now, to elaborate a little bit more about 30,000-foot level view with special and common cause, I'll be using an example of the time it takes someone to commute from home to work by way of car. The question is, would their time be about the same to the second every day? Well, the answer is no. It might take them 25 to 35 minutes. This is common cause variability. If it took us an hour one day for this commute, then we can say that is special cause. An unusual event occurred. Perhaps there was a major traffic accident or we had inclement weather. But let's consider that we want to reduce the amount of time it takes us to commute. So we establish a goal of 32 minutes. It takes us 33 minutes, we say, what happened? We did not meet our goal. We talk about it. But if it's 29 minutes, we don't talk about it since we met our goal. But I just said that we shouldn't do that. 25 to 35 minutes was our range of common cause variability. But that's what happens all the time. We establish goals within our common cause region and use red, yellow, green scorecards to indicate when we did meet a goal or we did not. Leads to a lot of firefighting. If we have common cause variability and we don't like the answer, we need to change our process. So let's consider we left a half an hour earlier. Now it takes us 18 to 22 minutes. We've reduced not only the average value, but also the variability. The point is that if we got common cause variability, we've got to do something different to the process. But that's not how traditional scorecards are shown. They don't talk about the separation of common and special cause variability. In addition, red, yellow, green scorecards don't make a futuristic statement. If we had a futuristic statement and looking out the windshield of our car, we see that something, so to speak, is not desirable, we need to take action. That's what we'd like to have as far as performance metric report outs. So let's re-examine this set of data. I'm going to use an individual's chart. Now, an individual's chart calculates also the upper control limit, or UCL, and the lower control limit, LCL. If there's no points exceeding those two parallel lines, and there's no trends relative to those lines, we say our process is stable. Nothing has changed. Quite a different picture from the red, yellow, green scorecards. The red, yellow, green scorecards gave us false signals or false indication relative to improvements and non-improvements. If we have a recent region of stability, though, we can also now make a statement about the future. The next obvious question is, what do we predict? If we consider the data from our recent region of stability to be a random sample of the future, we can build a histogram that describes what we can expect in the future. If we turn that distribution on its side, put our 2.2 value in, that's our criteria, we can then look at the area end of the curve to the left. That represents the frequency of time we expect our metrics to be read not only now, but in the future. Now, a better way of presenting this information is a probability plot. This plot might look intimidating initially, but it's quite easy. On the vertical axis, we've got percent less than. So now what we can take off of a probability plot and the area value directly. So what have we done with this particular illustration? Made the statement that nothing has changed, and we got about a 33% nonconformance if we're using a value of 2.2 as a criteria. Now the question is, how do we present this form of information in a 30,000 foot level report out? So for continuous data like this, where we have one value, we evaluate an individual's chart like shown. We notice that in this chart, there's 2 additional parallel lines. If there's no point that breaks these lines, and there's no trends relative to these lines, we say our process is stable and nothing has really changed. Quite a different picture from the red, yellow, green scorecard. The second step for this particular set of data is to describe how we're performing relative to what we desire, this being the 2.2 value. Now with 30,000 foot level view, we put a statement below that describes how the process is performing in words that everybody understands. In this case, a non-conformance rate of about 33%. We have software that can generate that statement automatically. Now initially I asked, is there a better way for those various scorecards? And the answer is yes, there is a better way, 30,000 foot level reporting. 30,000 foot level reporting is a component of the IEEE system. IEEE provides an organization with a roadmap for operational excellence. A 2-week training session provides the details of how to create this operational excellence system. In this session, I described issues with traditional scorecards. Describe also how to convert a historical-based scorecard to an integrated enterprise excellence predictive performance report out. If you'd like to see how the described techniques could be applied and be beneficial in your organization, let's set up a time when we can have a discussion. My contact information is included in this slide.